let's get started. As normal, first thing you want to do is put your name and date into the program. So just put in a couple of one-line comments with your name and today's date. And then underneath that, put in a multi-line comment, which in Python is triple speech marks. So always start your triple speech marks and end them, and then go back in between them to actually put your comment. So we need two things here. We need the purpose of the program, and we also need the functional requirements of the program. Right, so the purpose of the program is to convert an inputted, to convert a decimal input to its binary equivalent. Right, so that is the aim of this program. That's all it's going to do. Now, as you know, the functional requirements are made up of three specific areas: from the inputs, the processes that the program will carry out, and any outputs the program is expected to output. So, inputs to this program, I'm going to say, because again, I want to include the theory, I want to include the number of places. So I'm going to just put the number of places the number has to be displayed in, it has to be represented in. What else do we need as an input? We need to know the decimal number to be converted. Processes, a couple of things that I want to process in this. I want to convert the number to binary. Right, so that's definitely a process, but before we get to that, I want to validate the user input. Any user input would make sure that's valid. And also I want to find the range of decimal values given a set number of places. Okay. What else do I need to know? I'll also want to find the exponent. Because we want to use base, I want to find the base. So base, exponent and place order, those are three things that you should be very familiar with now, having investigated number systems. The three things number systems have in common: they have a base, there is an exponent, a power, and also the place value of the digits, the way they're displayed. So that's what we're trying to emulate here. I think that's all we need there. Now, the outputs from the program, it's going to be one statement. So a string message to display stating the original number and its binary equivalent. Yeah, that's all we need. Okay, so anyone who reads this program now has a clear idea of what the program's going to do. Yeah, the purpose of it is to convert a decimal number to binary, and how it's going to do it. It's going to get some inputs, it's going to do some processing, and the program should output. So in the future, if you are updating this program and you've forgotten, you'll be able to go back there and read that, and you'll be quite happy. So let's declare what we're going to need here. So we want to declare our variables. First one we need is original number. original number. So it's all one word because the computer is going to treat it as one memory location. If you separate those words out into original and number, then Python will treat that as two memory locations in RAM and you will get an error. We need an assignment statement and we're going to set this up to be an integer. So let's put in a comment. So it's an integer variable and it will store the user input. Now we then need, I'm going to make another variable because I want to use in this output message, it's a string message to display the original number and its binary equivalent. So I know I'm going to be processing, so I'm going to need a number to process with. So I'm going to call this processed number, and I'll just do num for short. Start that off at 0 as well, and I'll put in here a copy of the original number value to process with. Okay, that'll make sense as we go through this. Next variable that we're going to need is the converted, the end result, the binary equivalent. So we'll call it converted number. See, we're given these variables meaningful names so that anyone who's reading this program will actually be able to understand the purpose of the values being stored in those variables. Right, so I'm going to store converted number. I'm going to declare that as a string. So it's a string variable. And the reason for that is we're not going to do any binary additions. So we don't really need to store, it will be much easier and more efficient for the program to concatenate the ones and zeros at each place value rather than working with numbers. Okay, next one we're going to need is base. Now, I could not have put this in because we're only dealing with converting to base 2. But I'm going to put a 2 in here and set, because I want to use the variable base in my calculations rather than that number 2. And it means in the future, if you want to adapt this program to work with different number systems, perhaps all you'll need to do is change the base, but we'll talk about that a bit later because there is more involved in it. Right, so what am I going to put in here? So it's an integer and it will be used to calculate during processing. Alright, right, next what we're going to need, exponent. I want a variable called exponent, and that is going to be an integer because we'll use that in the calculations as well. So it's an integer and it will be used to calculate places, the number of places that you want to express your answer in. Now I'm going to make number of places an integer. I'm just moving these along to make it easier to read. So it's an integer and it will store the number of places. The conversion will display to. Yeah, that will make more sense as we move in. Now, two things that you might not have considered, but that you will have studied by now, and I think it's important to include it in this so that you can see the power of it, and it's the range. If you're saying, I want to convert a number, but I only want it to display it to 4 places, then that's 4 binary digits in this particular conversion. So what's the maximum range of 4 binary digits? Well, we know it's 15. And what's the minimum range? Well, we know it's 0 because we're working with positive integers at the moment. We're not using 2's complement. We're not working with negative binary numbers. So I'll put a variable in here called min range, and we can set that up just to be 0. We won't need to change that because, as I said, we're just working with positive. So it's the minimum integer value, and max range. We'll start it off at 0. Oops. We'll start it off at 0. Oh God, what's going on? We'll start it off at 0, but we'll change it. We'll calculate it as we go. So this is the maximum integer that can be expressed in a specific number of bits. Now, bits is in this context is the same as places, isn't it? Because it's 1 bit per place for binary. Right, that should do us with the declaring of the variables. Now we move on to the input section. So I'm going to put a dotted line here, input section, and we'll handle our inputs to the program. So the first thing I want to know is how many places. So number of places, and that's going to be, you can see number of places as an integer, so we want to cast it as an int, and what we pass into this int function is our input function. So the returned value from input will be turned into an integer before it's stored, before it is assigned to number of places. So inside the input we will put our message. So enter the number of places, and we'll say max 8 because we're only working with 8 bits. The conversion will be expressed in. Right, so that's quite long. It's getting to the kind of maximum I would want for an input. Remember to leave a space after your colon here so that the user doesn't click enter, click space before they enter something, because you'll end up with an error, because that space, as you know, is an ASCII character code 32. So it does have a value in Python, so you need to watch out for that. Okay, so now I want to validate this. So while number of places is less than 1, or number of places is greater than 8, I want to ask the user to re-enter. Alright, now I could type all that big long thing out again, but what I'm going to do is just Control C to copy it and Control V to space, and no, don't forget your assignment operator there. Now we need to change this message because it is an error message, so we need to say error and enter. I'm just going to delete that. A number between 1 and 8. Just make it more specific. Now, 2 lines there, line 35 and line 36, and we've made our program more robust by adding this, because the user will not be able to put in 0 and the program run, or they will not be able to put in a number above 8, 9, and it will ask them to re-enter. So this while loop has a condition. Number of places is less than 1, or number of places is greater than 8. So this is a complex condition because it's made up of 2 simple conditions. Here is your operator. here is your variable, and here is your value. So it's two values that are being compared, and it will result in either a true or a false. Because we're using this OR operator, only one of these simple conditions needs to be true in order for this to execute the code inside it. So if the user has put in a number that's less than 1, this will execute, or if they've put in a number that's greater than 8, it will execute. So I will test the program now. I wouldn't put in a validation and not test it and move on with the program, because the whole point of this is to make sure that it's working. So I've saved my program as decimal to binary converter. You do the same, so Control S and then F5, or press the wee green arrow up here to run the program. So it's saying enter the number of places, so we're in this line here, line 34, enter the number of places the conversion will be expressed in. So I'm going to put in 9, which I'm expecting it to error and run this line 36. And indeed it does. It's moved into error, enter a number between 1 and 8. So this time I'm going to put in 4, and then press enter. And that's been accepted into the program. Because there are no further lines of code in this program, the program has terminated. Perfect. So we can move on now. We're assured that that part of the program works. The next thing we're going to do is we're going to ask the user to put in a number. And because we now know how many places, we can put in the max range, so we can make their input and validate their input a bit better. So we need to now calculate the max range. So the max range will be, now how would we work out the max range? I know you're thinking, what variables have we got? We've got base and we've got exponent. Are we going to need those to work out the maximum number? Now, if I digress for a moment, and if we think about the powers, 2 to the power 0 is actually 1. So that's the first place, is 2 to the power 0. So we're going to have to remove 1 from our calculation. So let's do that. So the max range is the base to the power, which is 2 asterisks in Python, and we need to put brackets here. And what we're going to do first of all is number of places. So 2 to the power 4 is 16, but you can't actually express 16 in 4 bits. 15 is the maximum you can express in 4 bits. So you can see that we're going to have to remove 1 from this. Now, let's go down here for a wee minute, because you might not be following what I'm saying. So the base is 2, to the power 0 is 1, alright? So 2 to the power 1 is 2. 2 to the power 2 is 4, and 2 to the power 3 is 8, and 2 to the power 4 is 16. But we can't express 16 in 4 digits, 4 bits. We can only express 15. So that is why we need to remove 1. Okay, so number of places minus 1. Now I'm going to print out max range to test this. And to make it a meaningful print message, I'm going to just concatenate it. So obviously I need to put that in speech marks. Yeah, that should do. Right, so save that and then run it again. Now enter the number of places, so I'm going to put 4 in. And the max range is coming up as 8. Is that right? No, it isn't. So that means that we've got an issue here on line 37. So it's not number of places minus 1. It's number of places, yep. And then this whole thing gets a minus 1. Right, so let's save that and run it again. So we're going to say 4, and this time it should come up with 15. Now, the reason that that's worked like that, if you think about it, so 2 to the power 4, right? And I'm going to put that in brackets actually. Oops. 2 to the power 4 is 16, but 2 to the power 4 minus 1 is 15. Because it's 1 less, because it's 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, but it's 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0 gives you the maximum before you move on to the next exponent. I hope that's clear. If it's not, you need to stop and have a practice with that until you're 100% on it. Go back to your computer system notes. Right, I'm happy. I can move on. It's clear in my head. Alright, so I'm going to take that print statement out. It was just there for testing. I've tested it. My max range is now working. So I can use that max range in my next input, which is for the user to input the actual decimal number that they would like to have converted. And now that we know how many places that they want it expressed in, we know the range of, acceptable values that can be used. The next thing we want to do is the original number. Is assigned int input, enter a number in the range, and we're going to add on to this. We're going to concatenate to this string using the string concatenation operator our variable min range. So because it is an integer, it needs to be cast as a string. So str min range, and let's put in a space there, one of them, space, and this time str max range. Concatenate that with a space and then one of them. Right, so we want to test this now. What happened there? Do you know what? I think I'm going to hit enter a few times to give me some space. Okay, so let's save that and check that that's working. So enter a number. How many places? So 4 places. So the range, enter a number in the range 0 to 15. So if I put 17 in here at the moment, it's not going to error because I haven't actually validated the input yet, but at least I know that I'm getting the correct range. I'm going to test that again. So F5 it again. I'm going to put in 8. Now what's the maximum for 8? 255, because 2 to the power 8 is 256. Excellent. Right, let's validate this now. So while original original number, and we can use the max and min range is less than min range, or original number is greater than max range. Then what we want to do is, I'm going to copy that line and paste that in, Control V, paste it in. So we want to error enter a number between, yeah, that should do it. Now I want to explicitly separate these two simple conditions, because this while condition is actually a complex condition. There's two separate things being tested for, so we want that. So original number is less than min range. That will either be true or false. And then the next one that's been tested is original number is greater than max range. So the or means that either this is true or that is true. If either one of these simple conditions is true, this line 40 will execute. If they are both false, as in the user put in a number, an acceptable number, then line 40 will not execute, and the program will jump past the while down onto the next line of code to be executed. So we need to test this now. So I'm just going to run it. Control S, save it, F5, run it. Number of places 4. This time I'll put 17 in, and I should get an error message. Yep, error, enter a number between 0 and 15. So let me put in 21. Enter a number between 0 and 15. I'll put in 0, and it should work. Yep, that's fine. So it's working. We can move on safely. Right, so the next thing that we want to do now is, that's us got our inputs, we want to move on to the process data. So let's do the process section. And there's going to be a few things happening in this process section. First thing that we want to do is find the exponent. So why not, let's write that in here in a triple speech mark, just so that we can keep track of what we're doing. So the first thing, is number 1, find the exponent. Number 2 is to loop, using a fixed loop through the places. Yeah. And as we loop through, we're going to calculate the number, the current number, based on the base and exponent, and compare it to the original, which is, remember up here we said the original was going to be called, let's see the name of it, processed num. So I'm going to put in processed num there to keep track. Okay, so let's just go ahead and do that now, and we can refer back to that. If we want to change it, we can. So it's a for loop, but before that we need to work out the exponent. So exponent is assigned, and it is the number of places minus 1, because remember the exponent starts at 0. So if we want to express our answer in 4 bits, we want it to finish at 3, 2 to the power 3. Now we want to establish processed num, is assigned original num. Original num. And the reason that we're doing that is because we want to have original num with the original value in it that we can use in our output statement. So we're going to now calculate with this processed num. And we can edit the value in there or change the value in there, and it will not alter the value that's stored in original num. So we need to start our loop now. So for index in range, and it's the number of places. So for, say, 4 places, if base to the power exponent, exponent is greater than processed num, then we're going to assign something to converted number. Converted number. Now what is it we're going to assign to it? So if the base multiplied by the exponent, so for instance 2 to the power 4, if that's greater than the processed num, because we've got, maybe say they're trying to find 15 and there's 4 places, so base to the power 4 would give you 16, so that's too big. So we're going to assign a 0, aren't we, onto converted num. But the way that's written there, what would happen is it would replace what's in converted num with the string 0 there. What we actually want to do is concatenate this onto what's in converted num. So we need to do this converted number plus, this is similar to a running total, the algorithm for running total, but it's not adding something up, it's joining together. It's a string joining together a string. Right, so that's what happens if the number's too big. Else, so if the number's not too big, what we would normally do is we would put a 1 in to the placeholder and subtract that exponent from the number that you're calculating. So let's do that. So we'll say converted number is assigned converted number, plus 1, concatenate 1, that is, not, well, you're not actually doing a calculation on it. And what we also need to do now is in this processed num, we want to assign to it a new value. So what we want to do is say processed num, what's already in there, subtract, and then I'm going to put in brackets what we want to subtract. And what we want to subtract is the base, to the power of the exponent, right? And then what we want to do is we want to come out of the if else, but we're still in the for loop, and we want to subtract 1 from the exponent. Is assigned exponent minus 1. Right, so let's test this now. So what we want to do, we're out of the for loop, do you see that? So what we want to do here is print out the str, and we'll put in there original, God, I can't spell, original number, and then concatenate it, is equivalent to, concatenate the converted number. Now converted number is a string, so we don't need to use the str, number, and we want to concatenate onto that converted number plus in base plus, and then we could put here str base. And what else do we need? We need another bracket to finish that off. So let's save it and then test it. So enter a number of places. I want to work with 4, and the number I want is 15, because I know it should be 1111. Oh, I've made a spelling error. Original num is not defined. Original number? Why did I say num? Right, assistant, I don't need you. Original number, where is it? Where have I said this? Up here. Okay, that's my mistake, sorry. So 4 places, and I want to convert the decimal number 15. So 15 is equivalent to, where is it? 1111 in base 2. So that's correct. Let's run it again. And this time we'll do 4 again, and we want to find the number 1. So that should be the equivalent of 0001 in base 2. Right, let's run it again. Remember, you need to click in here to your code and then press F5. I'm going to use 4 bits again. I'm going to number 2, 0010, so that's looking correct. It is working. So that print statement actually is the output. We don't need to, so let's hit enter a couple of times and put in our output section. So output section, and that's it. Now let's test it for a different number of bits. Let's test it for 8 bits. So F5, how many places? Let's go for 8. Let's put in 255. We should end up with 8 ones here. 1, 2, 3, 4, 5, 6, 7, 8. Right, let's test this again with 8 bits, and this time we'll test 1, and it should be 7 zeros and a 1 at the end. Yep. Let's test it again. Now I know 128 is the 8th bit, the most significant bit, so let's try that. So 8, and I want 128, so it should be 1 with 7 zeros. Great, that all seems to be working. Good.